Just 30 extra minutes of physical activity a day can boost your brain function by up to 20%, while every 30 minutes spent sitting down makes it significantly worse. This is according to a fascinating, fresh new study just published in the International Journal of Behavioral Nutrition and Physical Activity, and it sheds light on this very connection. It explored how daily physical activity impacts next-day cognitive performance, and the results were absolutely incredible. As a holistic doctor for almost 15 years now, this is something I talk about regularly with my patients, how exercise can improve their physical and mental health. But maybe now I can add another string to my bow, so to speak, and tell them that it probably also increases their cognitive brain health as well. So, they studied 76 adults living in the UK and found two key results. Number one, physical activity was associated with a better episode and working memory performance. And number two, sedentary behavior, doing nothing, on the previous day was detrimental for working memory. Let's have a look at the findings in some closer detail though. These results are fascinating. First off, participants who engaged in just 30 minutes of moderate to vigorous physical activity, or MVPA for short, showed significant cognitive improvements the next day. Their episodic memory scores went up 0.15 standard deviations, but their working memory scores, that's things like problem solving, went up by 0.16 standard deviations. Now, you might be thinking, what the heck's a standard deviation? A standard deviation is a statistical term that measures how spread out data points are in the data set. In this case, it's used to quantify how much better the participant's memory performance was compared to the average or the baseline. When the study says that episodic memory scores were up 0.15 standard deviations higher, it means the participants performed better than the average after engaging in those moderate to vigorous physical activity exercises, MVPA. Similarly, the 0.16 standard deviation improvement in working memory indicates a small but measurable boost in performance compared to their baseline or usual functional level. In other words, that equated to a modest 2% increase in memory scores, but actually a whopping 20% improvement in working memory scores. The 2% may seem small, but for tasks requiring mental sharpness, even small improvements can make a big difference. And don't forget, the working memory score, that's things like problem solving, went up a massive 20%. Now, this study doesn't mention any cumulative benefits over time, but it is entirely possible and plausible that some of this effect could persist. And maybe you could build on this every day with exercise. That would be very nice. Working memory means mostly problem solving. This refers to the brain's ability to temporarily hold and manipulate information needed for cognitive tasks. It's kind of like your mental scratch pad, if you will, that helps you process, store, and use information in real time. Think of it like the mental workspace, where you can juggle multiple pieces of information and then basically make sense of it. Examples of working memory include mental math, adding numbers in your head, or maybe calculating a tip at a restaurant, following directions, reading a map and remembering it, and executing the series of turns, just like following a recipe or driving directions. Problem solving, holding variables or ideas in mind while working out a solution. And reading comprehension, remembering what you've just read to make sense of the sentence or a paragraph. Why does all of this matter though? I think it's fairly straightforward, but working memory, that problem solving, is crucial for everyday tasks that require concentration, multitasking, and decision making. It's especially important for activities that involve planning, reasoning, and learning. Improvements in working memory, like the 20% gain found in this study, which is huge, could lead to noticeable enhancements in productivity and mental sharpness in daily life. What kind of exercise, though, do we need to do? What did the study look at? Do you need to be a gym junkie? Well, actually, we don't know from the study. In the study, MVPA, or moderate to vigorous physical activity, annoyingly wasn't actually defined, though the lead author, Dr. Bloomberg, has later clarified in a separate piece. Quote, This isn't just about high-intensity workouts. Moderate or vigorous physical activity means anything that gets your heart rate up. This could be brisk walking, dancing, or even walking up a few flights of stairs, end quote. So the suggestion here is that you don't need an expensive gym membership, crazy gym equipment, or be pounding 500 kilogram squats or deadlifts either. You can just walk briskly, dance like I did with my kids this morning, or even run up a few flights of stairs. Interestingly, as I read this and record this, I'm thinking of actually what my kids do, and actually it is these things. I often say that we should learn from our kids. They are very instinctive, natural creatures. And honestly, I think they have it right most of the time. They naturally do these kind of MVPAs. On the flip side of all this though, sedentary behavior, defined in the study as activities generating fewer than 100 movements per minute, had the complete opposite effect. The study noted that each additional 30 minutes of sedentary behavior on the previous day was associated with a reduction in working memory score of 0.05 standard deviations, end quote. In other words, sitting too much could negatively impact your memory. To give it a percentage like before, that 0.05 standard deviations would equate to around 1% for memory and 7 to 8% for working memory or problem solving, respectively. Again, doesn't sound huge, but what if that adds up over time? And I actually think 8% is pretty good going. It's a pretty big loss for problem solving. Could sitting lower your cognition and harm your brain? It's a scary thought, especially as I'm sitting at the moment. The study also showed how sleep affects brain power, but I'm going to cover that in a separate episode. I'm focusing on the exercise part today. So this study has demonstrated some pretty interesting stats on physical activity and brain power. Let's just review them again quickly though. Number 1, for every 30 minutes of physical activity, episodic memory increased by around 2%, but working memory, problem solving, improved around 20%. Huge. Number 2, sedentary behavior was associated with a 0.5% decline in cognition for every 30 minutes spent sedentary. I think that sounds quite impressive and actually quite worrying at the same time. But as always, we need to look at the study and think, can we actually rely on this? I think we need to answer a few simple questions. Was it any good? Did it have enough power of the study? Was it a randomized control trial or was it an observational trial? That's important and we'll come back to that. Was this in humans or was it in animals? Let's have a look and answer these questions. First off, this was an observational, micro-longitudinal study, meaning participants were tracked over a short period of time, 8 days in this case, in their daily environment, rather than in a lab setting. This was not, unfortunately, a randomized control trial. So, unfortunately, we cannot definitively establish cause and effect relationship. It would have been nice. Instead, it highlights the associations between physical activity, sleep, cognitive performance, I should say. 8 days doesn't sound like a lot, but is it enough? Well, the point of this study was to look at what happened the next day, not really a long-term longitudinal study. So, yeah, 8 days is probably sufficient time to see if there's an association there. I think we can probably give this one a thumbs up. It wasn't, unfortunately, a randomized control trial, which it is disappointing. I think it probably could have been a randomized control trial. The sleep part, no, but the exercise part, I think it could have been. So it's a bit disappointing that it wasn't. It would have been challenging, but yeah, definitely possible. And then it could have given actual proof of causation. Just think how powerful that would have been to prove once and for all, definitively, that exercise improved brain performance. But now all we can say is there's an association, which is a shame. Exercise, I think, could have been pretty easy to make it an RCT. The sleep part, of course, would have been very tricky, if not impossible. Let's have a little look now at the population of the study. Was it in humans or was it in animals? This matters, of course, because human studies are understandably much more useful to us humans than animal studies are, and they're less prone to criticism or open to criticism. Thankfully, this was a human-only study, no animals involved. They looked at 76 cognitively healthy British adults aged 50 to 83. Now, you could argue that if you aren't British or in those age groups, that this doesn't apply to you, but I think it probably applies to most, if not all of us. Were there enough patients in the study though? Now, I've discussed this in other videos, like my one on diabetes and dementia. We call this power. Was there sufficient power to reliably draw any conclusion? In this study, We have 76 participants and 291 observations in total. More is usually better, but actually this is a reasonable sample size. So yes, I think we can give it a thumbs up for sufficient power. What about the measurements though that were taken? Were these okay? Were they accurate? Were they reliable? Well, in this study, they used accelerometers to track exercise and sleep. Sleep stages were also evaluated using a validated machine learning algorithm, which was based on polysomnography, which is the gold standard test. This adds reliability. Cognitive assessments were also done with standardized testing. So this all makes the results more reliable, but of course not totally infallible. But hey, at least nobody was guessing anything here. Were there any problems? Well, we've already alluded, of course, to a few. 8 days isn't very long to study someone for, and the sample size wasn't huge, but 291 observations in 76 people is reasonable. The observational design we've mentioned isn't ideal, of course, and it could have been an RCT. Observational trials are okay, they're kind of useful, but they're really far from ideal. It was also potentially quite a homogeneous population sample. And this means that basically they were kind of all the same. They didn't break down ethnicity or any other variables. We just know that they were British adults, 50 to 83 years old, and cognitively healthy. What does that mean, cognitively healthy? How does it vary also for people with dementia or mild cognitive impairment? What about neurodivergence like ADHD or ASD? We just don't know from the study. There's also a lack of clarity on what sedentary activity constitutes. Were they sitting on their butt all day like I'm doing recording this? Or were they actually sitting there doing crosswords or 3D Death Star jigsaw puzzles? Now that's very different, of course, to doing nothing and just vegging out watching Netflix and eating ice cream all day. There isn't also any long-term data. And was this effect cumulative? What happens after 8 days? Does it still keep improving? And so on. So, all that said, is this study useless? No, I don't think it's useless. I think we can definitely look at this and say, yeah, there were some issues, but overall, some pretty good results actually. And I think it's a pretty reasonable study. And I do think it adds to our current knowledge and helps. It also mirrors kind of what we already know. So what are the practical takeaways from this study? Well, I think it was pretty clear that being active was beneficial to cognition, even if only the 2%. But again, remember that working memory was 20%. This makes perfect sense. And you might think, of course, surely everyone knows this. Well, yeah, they probably do. But how many of us actually do these things? As I sit here writing and, of course, recording the episode, I'm sitting down and I'm left wondering how much more could I be doing to help my cognition? Actually, after this is recorded, I am going to go and do a workout. Otherwise, here are 3 simple, actionable tips based on this study's findings. Number 1, understandably, is move more and sit less. Maybe think about incorporating moderate activities into your day, whether it's a brisk walk during your lunch break or dancing in your living room, like I was doing this morning with my kids. Remember, just 30 minutes can make a difference. Number 2 is to prioritize sleep and sleep quality. Aim for at least 7 to 9 hours of sleep every night. I'd really recommend probably 8 to 9 though if you can. And think about establishing a calming bedtime routine and consider reducing screen time before bed to maximize your deep sleep. And number 3 is to track your progress. Think about using a fitness tracker to monitor your activity and sleep patterns. Remember, small, consistent changes can have a lasting impact on your brain health. So by integrating daily physical activity with quality sleep, you're really setting yourself up for improved memory, stronger focus, and better overall well-being, as well, of course, as reducing your risk of almost every single chronic disease out there.